This video will be going over 7.1 and 7.2 in our trig book, going over oblique triangles and laws of sines, and law of sines, and then law of cosines and area of the triangle. So keys to success is what is an oblique triangle, because when do you know to use that, and know when to use law of sines and the law of cosines. And then there's going to be some formulas that are going to be applied here, especially with area of triangle. Okay, so oblique triangle is a triangle that doesn't have a right angle. So now we're looking at, okay, what happens in a situation if we're not looking at a right triangle? So what we have in this case is, since right triangles, just remember on this, for a right triangle we have the Pythagorean theorem. To be able to find side lengths, and then we have sine of theta is equal to opposite over hypotenuse, cosine of theta is equal to adjacent over hypotenuse, and tangent of theta is equal to opposite over adjacent. And we had all that with a right triangle. Well, now we don't have a right triangle, so how do we relate angles and side lengths? And that's where we have the law of sines and law of cosines, and they work with non-right triangles. So here's our right triangle. Then this right here, sorry, bumped my elbow, would be an example of an oblique triangle, where we could say that this is theta right here. And then what we do instead is we treat it still like how we would do a right triangle in the Pythagorean theorem, where we have A, B, and C. Well, this would be, and this is theta right here. We can say that this is C, we can say this is B, and this is A. And then we're going to set these theorems up. Okay, well, the law of sines is also, I like to refer to it as the law of opposites, because it's a proportion, which basically just means two equal fractions or ratios, and the ratios are basically the sine of an angle over its opposite side. So you can see that sine of angle A is right here. Here's angle A, and side little a is opposite of that. These two are opposite of each other. Sine of B, here's angle B, and side B is opposite of that. So these are opposite of each other, or I should say these. Sine of angle C. Remember, angles are in capital letters and side lengths are in lowercase letters when we do this. So capital C, angle C, and lowercase c, side C is opposite of that. And that is our law of sines. So application actually using law of sines. So here's an example. We have an oblique triangle. There's not a right angle. And we're given two sides and an angle. Well, what we can do here is we can say side, let's say 10 is equal to sine of 45, and that's equal to 12 over sine of angle B. Or I can say it the other way, sine of 45 over 10 is equal to sine of B over 12. And then we can solve for angle B. Now, this is a situation also when we have this. There's a couple of situations where we use the law of sines. In this situation, what we have is a side and then a consecutive side and then an angle. This one has two solutions to it. When we have that, if we have an angle and then an angle and then a side, that's okay. This has one solution. In any other applications of opposites, we'll have one solution, but anytime that we have two consecutive sides and then the angle after that, that actually is going to give us two solutions. So when we go through and solve this, we're going to get sine of 45, remember, is the square root of 2 over 2. So we have the square root of 2 over 2 times 12, and then also divided by 10. So this gives us 6. And then we can reduce this. And I'm doing it this way because I don't have my calculator. So this gives me 3, and this gives me 5. So I get 3 square roots of 2 over 5. is equal to sine of b. And so then I'm going to do inverse sine of that side length. 3, sorry, that's my square root sign. 3 square roots of 2 over 5. And that's going to give me the answer. I guess I better grab my calculator. So remember, in this case, we can only do inverse sine of a value that's between -1 and 1. So when we do 3 square roots of 2 divided by 5, we get about 0.8485. So that's going to work. So we can just go ahead and do inverse sine of that. We get, when we make sure that our calculator is in degrees, because we started out in degrees, we get 58.05 degrees. Okay, so now this is supposed to have two solutions. So this would be the solution that is an acute angle. We should also have for B an obtuse angle. So how we find that is by doing 180 minus the angle just found. And so that would give us an angle between 180 and 90, which is an obtuse angle. So theta 2, or angle B2, we'll say angle B2 is equal to 180 minus 58.05, which gives us the answer of 121.95. And so that would give us our second angle for this information that we're given, where this is our obtuse triangle and this would be our acute triangle. All right, so it says solve for the triangle. So the triangle is that you have to find all three pieces of information that are missing. So now we found what angle B can be equal to. So we'll be like B1 and B2. This would be 58.05 degrees. This is 121.95 degrees. Then we also have to be able to find our C value and also our length of C. So we know that in the case of angle C, this would be 180 minus 58.05 minus 45, which is going to equal 76.95. And then for the obtuse angle, this would be 180 minus 121.95 minus 45, which would equal 13.05. And so those are our two possible angle C's. And then the length for C, we can use, again, the sine law of sines. So we can do 10 over sine of 45 is equal to C over sine of, we'll do 76.95 first. And so we get C is equal to 10 times sine of 76.95 divided by sine of 45. And that gives us the answer of 13.78. So this length would be 13.78 over here. And then we can do the same thing with the angle of 13.05. So we would do 10 sine over sine of 45 is equal to C over sine of 13.05. Solve for C. We get C is equal to 10 times sine of 13.05 divided by sine of 45. We plug that into our calculator and we get the answer of 3.19 instead. And so that would be solving our triangle. And in this case, again, remember, this is an ambiguous case because it is a side-side angle with the information that we were given. Okay, so this is the law of cosines. We use the law of cosines when we have side angle side or side 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 triangles. There's no opposites. Basically, we're just given this information. And when we write this, we mean these three things consecutively. So something that just looks like, and this is angle C. That would be an example of that. Or if you have all three sides of a triangle, that would be the side side side. So there are other ways to write this. A lot of times they will do one where it's also a squared equals and b squared equals. But essentially, if you treat this as your only formula, and that either the side you're trying to solve for is C or the angle you're trying to solve for is angle C, you'll always be able to do this correctly. So as you can see in this one, angle C or side C is unknown. These are what you're trying to solve for, and you always know side A and side B. Okay, so these would be examples of applications of the law of cosines. This first one here is side angle side, because we're given a side, then an angle, then a side. This would be an example of side, side, side. So the way that this works up is that this is angle C, this is side C. And then again, you see we have angle C over here, and that's what we're trying to solve for. And then that's side C. So we could also call that angle theta, and that would replace this angle C in the law of cosines. So we start out with C squared is equal to 11 squared plus 13 squared minus 2 times 11 times 13 times cosine of 27. That's basically all something you can put into your calculator. You can simplify it individually if you want, but you can just as easily go ahead and plug all of this into your calculator. 11 squared plus 13 squared minus 2 times 11 times 13 times cosine of 27, and you get the answer of 35.1721, we'll say. And then we have to take the square root of that, so we just take the square root of our answer. I always just do the square root of previous answer to be able to get it, so I don't have to type in this value up here. So I get 5.931, and so there's my C value right there. All right, so then we can go from there to also be able to figure out our other angles. So we could also then set up the law of cosines, where this could be angle C if we want, or we can use the law of sines, where we can do sine of 27 over 5.931 is equal to sine of A over 11, and then we can solve for angle A and then solve for angle B. All right, now in the case where we're given sine, 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 or sorry, not sine, sine, side, 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 we would just do 9 squared is equal to 4 squared plus 10 squared minus 2 times 4 times 10 times cosine of C, and then we would solve for cosine of C. So I would subtract 16 and 100. So that ends up being 81 minus 16 minus 100. And then divide by negative 2 times 4 times 10, which would be negative 80. So divide all of this by negative 80, and that's going to equal cosine of C. And notice all I did is the stuff, I wrote down the stuff I could easily do in my head. So I'm going to go ahead and plug this into my calculator, and I'm going to take inverse cosine of that. So I'm going to do inverse cosine of 81 minus 16 minus 100 divided by negative 80. I need to make sure that I put this numerator in parentheses. So I do inverse cosine, which automatically opens up parentheses, and then I do parentheses again, and then do 81 minus 16 minus 100. Close my first set of parentheses, divided by negative 80, and then close my second parentheses, and I get that C is equal to 64.06, and so that's angle C. And then again, I can go through, after I get that, I can do law of sines to be able to find the other two angles. All right, now let's talk about the area of a triangle using trig. It's those moments where you don't know the height or it's not a right triangle. So my preference is I actually really like this first one, which is anytime you're given a side angle side. This is just 1/2 a times b times sine of c. The 1/2 comes from, that the area of a triangle is a is equal to 1/2 base times height. So the b actually represents the base of the triangle, and then the a times sine of c is equal to the height. We also have this formula here of c squared times sine of a times sine of b over 2 sine of c. Anytime we have angle, angle, side, or angle, side, angle. And then we have this one. This one, last one here is called Heron's formula. And you use Heron's formula anytime you're given the 3 side lengths. And it has what's called the Heron's number, which is S. And it's found by adding the 3 sides and dividing by 2. So that's basically how Heron's formula works. So let's go ahead and apply this, finding the area. So remember, this one is side, angle, side. This one would be an angle, angle, side. And then this one would be a side, side, side. So with side, angle, side, we use the first one. A is equal to 1/2 times a times b times cosine of angle c, which in this case will be 1/2 times 20 times 25 times cosine of 15, which will be, this would be 10, so equal to 250 cosine of 15, which gives us the value of, we could do the half angle formula here, but let's not. 241.48 units squared because it's area. Okay, so with angle, angle, side, we're going to use the second formula. Okay, so this has to be side C, which is going to make this angle C. We can call this one angle A, and we'll call this one angle B. So we need to solve for angle A, which we're going to do 180 minus 48 minus 36, which is going to give us the value of 96. So that's angle A. So now we can just substitute all these in. So we have 20 squared times sine of 96 times sine of 36 divided by 2 times sine of 48. Okay, so this would be 400 divided by 2 gives us 200. All right. Then we can just go ahead and plug that all into our calculator. 200 times sine of 96. Make sure you close out your parentheses. Times sine of 36 divided by sine of 48. And we get the answer of 157.32 units squared. Now, there's one thing that I would say about this problem is that we can easily find either side A or side B with the laws of sines, the law of sines. So you could just do the law of sines to be able to find another side length for side angle side, and then use the first formula if you wanted to. Okay, so the second one, we're going to use Heron's formula. So first thing we have to do is find Heron's number, which is to add the 3 sides and divide by 2. So that's going to give us 32 divided by 2, which gives us 16. And then we do the square root, where we do Heron's number times Heron's number minus one side times Heron's number minus the second side times Heron's number minus the third side. So this gives us the square root of 16 times 9 times 1 times 6, which is going to give us 4 times 3 times the square root of 6, or 12 square roots of 6 units squared. All right, so again, just to reiterate these, we've got the law of sines, which remember is when you have opposites. And also remember with the law of sines that if you have side-side angle, that means it's an ambiguous case. Which means there's two solutions. One acute and one obtuse. And we use both of these when we're dealing with oblique triangles. And remember, oblique triangles just basically means it's not a right triangle. Okay, so then we also have the law of cosines. Remember on this one, we use it for when we have side, 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 or side, angle, side to be able to solve that. And law of sines can be written as a ratio of sine of the angle over the side, or it can be the side over sine of the angle. And that is basically kind of what 7.1 and 7.2 are going over in terms of applying these formulas and then also looking at the areas of the triangles.